So today we are going to start with external loads. So external loads are forces acting on a body from outside, and this might cause deformation, movement, or the structure can remain in equilibrium. In civil engineering, every structure is designed by first identifying this external load or loads. These external loads are mainly of two types. One would be the surface forces, I'll explain it in a while, and the other would be the body forces. So, surface forces are forces applied to a body through direct physical contact. Okay, and these forces acts because one object touches another. And few basic example would be a chair pushing on a floor, right? And in the bicycle tire which is pushing the road, your hand pushing a wall or a book which might be resting on table. Okay, all of these are surface forces. And a few civil engineering example would be a wall which is resting on a beam, a vehicle tire which is applying a direct force on the road, or the column load. Let's say this is a column which is applying a direct pressure on the foundation or footing that it is placed on. So all of these are examples. Now, these surface forces can be either concentrated if the force acts at a single point, okay, like that of a tire which is touching the road over a small area, or a column load transferred to a footing can sometimes be idealized as a concentrated load. And the second part or the second category would be distributed load. This mainly happens when the load is either applied on a straight line, which is called a linearly distributed load, or the load is distributed in a surface area. So, might be linearly distributed in a straight line and can be expressed in kilonewton per meter, which is load applied over a specific length, or it can be distributed in some specific area. Okay, and again, there is no restriction in how these forces could be distributed. Okay, even among linearly distributed load over a length L, the way it is distributed can be referred in Wx. And one more aspect would be the resultant force. The resultant force, where it is the force which can be expressed as equivalent to this whole load, and it directly acts at the geometric center of this. distribution. And coming back to body forces are forces that acts throughout the volume of the body without direct physical contact. So, in surface forces, there should be direct physical contact, and in body forces, it's not necessary to have a direct physical contact. And common body forces would be gravity, can be related to civil engineering. A few examples would be self weight of a beam, slab, column, or anything, or weight of concrete foundation, because gravity acts in all those structures, and it always acts at the center of gravity. All these body forces works at the center of gravity. This is one more differences. In one part we have the surface forces which acts at the geometric center of this distributed load, and in other forces we have the body forces where this acts at the center of gravity of the body. So this is for now, and we'll continue to next video later. So that's all for today. Thank you.